So earlier in the day, Eugene explained to us how important it is to actually move away from the executive function and start heading towards decisioning. And it's great if you know what to do, but what if you don't actually know what to do? Then that's where we start to get into the realm of running experiments and being able to actually rapidly turn things around. So with that in mind, I'd like to introduce Zeming Yu from Covermore, who'll be presenting our first microtalk on LightGBM. And the intention of this talk is to be just a short technical session to give you an example of how one of these crazy ideas you might hear about can actually be used in real life. So specifically, LightGBM and XGBoost, these are packages you might have heard about from Kaggle competitions because they're often used by the winners. And one particular advantage of LightGBM is it's very fast to run, which means, like I've said, you can actually test ideas very quickly. And in an increasingly competitive environment with split-second decision-making, therefore the ability for companies to get models into production very quickly is a key differentiator. So in his talk, Zeming is going to provide the intuition behind LightGBM and show how it can be applied in a sample data set, as well as then running through a few use cases in financial services. So please join me in welcoming Zeming to the stage.
Thanks, John. I'll keep this nice and short, so I don't want to stand between you and your lunch for too long. As Eugene said, as actuaries, we're all very familiar with GLMs. So we've been using GLM for a couple of decades. And I think in recent years, I've seen a lot of consultancies or companies starting to use GBM, so gradient boost machine. It's a machine learning technique. And one of the packages I came across while doing Kaggle is LightGBM. It's created by Microsoft, to my surprise. We know Microsoft is traditionally do closed source software, but they really got into open source, by creating this package. Also, we know that they bought GitHub recently, so they're really big on open source now. So just before diving into LightGBM, I want to talk about the different ensemble methods. So as Farhan alluded to be really predictive, you typically take a lot of models and leverage all their power together. So on the left, you got a single decision tree, right? So we should all be familiar with a decision tree. Say for example, you want to work out who's more risky driver. The first question you might ask is, are you over 25 or not? And then next, if you're over 25, then say what's the weather like? Some kind of decision tree. We should all be familiar with that. And then next, you got bagging. Bagging is where you take a lot of individual trees, and then you take their prediction and then average out all these predictions, so to give a more accurate result. But finally, we got boosting. So instead of averaging out lots of parallel models, you build one model and you look at the error. So the model you build might be very simple. You got lots of error, but it doesn't matter. You iteratively improve on these models. So you have a second model predicting on the errors, and then you keep going and do that for hundreds of times or thousands of times. So GBM is a boosting method. With other GBM algorithms, you have something called a level-wise tree growth. So when you grow a single tree, you grow one level at a time. But with LightGBM, they do things differently. They focus on specific leaves. So a leaf is a single question. So they're going to that single leaf and they keep going. They can go quite deep very quickly. So with GLM, we know that typically we do two-factor interaction, maybe three. But with machine learning, one thing to get used to is you can have very deep interactions. So by having that approach, you get a few benefits. So number one, you got fast training speed and high efficiency. So I tested that on my machine, comparing with XGBoost, it's much faster. You got lower memory use. So if you are got into machine learning, you discover that you're really short of RAMs, and they're all RAM hungry. So it's always good to efficiently use your memory. And then next, you got better accuracy. You can also do parallel and GPU learning. So parallel is like you have one machine learning model, but you're training that on a huge data set. I'm talking about terabytes of data. Um, so to run on one machine, it's going to take too long. So you can distribute that across multiple PCs. Typically, you do that on the cloud. And then also got GPU learning, where you can leverage your graphics card to efficiently build your model. Because on a normal PC, you might have 8 cores or 12 cores, but with a graphics card, you have thousands of cores. So people found that it's really efficient to use GPUs. Yeah, and as a result, you're able to handle very large data sets. So the first project I did using LightGBM was actually a Kaggle competition. So as Eugene mentioned, Kaggle is the machine learning platform where you can learn and practice your skills. So I think this one ran around the same time last year. I was having my second son, and even the day before my wife was giving birth, I was still obsessed with this model. And then she to this day she still brings that up. So yeah, so this just shows you I'm just really obsessed with machine learning. So this competition is from a Brazilian motor insurer. They've published their data set on Kaggle. So it looks like this this table. So you got ID, which is probably some policy identifier, and you got a target. So target means if it's 0, it means there's no claim. If it's 1, it means that there's a claim on the policy. And next, you got a lot of variables. You got indicator variables, you got calculate fields, categorical variables. So one thing to notice, right? You might think you're doing real data science on Kaggle, but you are not, because you are given anonymized data, and there's nothing you can do with interpreting or applying judgment, talking to people, or the commercial context. There's nothing like that. Just pure machine learning. It's a narrow scope, but still it's good to give you the capability. So yeah, after many weeks, yes, so the competition finished, and the winner is a guy called Michael. In the winning solution, he used 6 different models. So 5 of them are deep learning models. One of them is a LightGBM. And by averaging out all these models, he gets even a better result than any individual models. So even though LightGBM is not the most accurate model, it still contributes to the winning solution. So now I will quickly go into a Jupyter Notebook. So for those of you that haven't used Jupyter, basically, if you want to do Python, use Python to do machine learning, typically you would use a notebook environment where you got your code, your result, your graph, everything all in one place. And you can also do your documentation while you're coding. Yes, so I'll just quickly go through. We can upload the notebook on the website for you to go over. Really, to learn this, I encourage you to get your hands dirty, because that's the only way to learn. All right, so first we load a bunch of packages. They range from machine learning packages or data processing packages called pandas, or got some other packages to save your data. And then we read the data in. Data comes from Kaggle. So once you log in, you can download it. As I said, it's all being anonymized. So these are real data from Brazil, but you won't be able to tell who the customer is, what the fields mean. Some people try to reverse engineer, to try to guess, this is this particular state in Brazil. So it's a lot of fun watching other people do that, and then take the take the insights into your model. Yeah, so this is data set. We need to identify all the categorical variables because they need to be treated differently. So the categorical variables are coded as 0, 1, 2, 3. You don't want the package to think that 1 is bigger than 0. They're just different categories. And then we can split the data sets into so training set and testing set. So when you build machine learning model, you typically do a lot of cross-validation. So you train on one data set, and you try to assess how accurate the result is based on another data set. And based on that, you can improve your parameters. And also we got X and Y all split out. So X are all the predictors, and then Y is the response, which is the claim, like yes, no variable. All right, next we feed a parameter set into the model. When you do Kaggle, that's when you spend a lot of time. You try to find an optimal set of parameters. That's called hyperparameter tuning. But in work, as we know, often the most important thing is not to get the most accurate model. It's to get decisions happening based on the model. It's to change the actions of the company. So I reckon in your normal day-to-day work, you probably don't want to spend weeks on parameter tuning. Just to get a good enough model will often suffice. So just very quickly, there are a few parameters that will be important to tune for GBM. So number of leaves. So for a given decision tree, how many leaves can you have? The more you have, the more complex the model is. And then you could suffer from overfitting. So you fit to the noise rather than the signal. And next you got learning rate, which depends on how quickly you converge a model. And then you got feature fraction, bagging fraction, where you can you throw away for one individual iteration, you randomly select some columns to throw away. And that actually, surprisingly, it actually helps the model to avoid overfitting and gets you a better result. So feature fractions where you might randomly throw away 10% of your columns, and bagging fractions when you randomly throw away 10% of the rows. That makes sure you are not dependent on any individual column. So next, we do a model training with early stopping. So early stopping means I train the model on one data set. I watch the result on the testing data set. And as soon as the result on the testing data set start to deteriorate, I know I'm starting to overfit. So I'll stop at that stage rather than keep going. So that's really helpful to speed up the process. So here we can see the models stopped on iteration 141, right? And then we can save the model in different formats. So in text format, JSON, or other formats. We can also look at what's called importance matrix. So if you're doing a GLM, you're doing a risk model, what you can do is quickly run a GBM and figure out the most important factors. You might have hundreds of factors, right? And so how do you know which factor to look at first? So GBM can quickly tell you, for example, in this case, PS car 13 is the most important factor. So, well, in real life, you would know what the variable means. You can start to talk to the underwriter, talk to the people to understand, is that sensible? Yeah, so feature importance is an important tool to assess or to understand the model. And then finally, you can calculate the errors and assess the performance. So yeah, we'll try and upload the workbook. So just wanna come back. So just got two more slides. So I want to cover a few use cases because that's all that matters, right? The technical side you can learn, but how do you turn the models into insights, into actions? So here are three use cases that we've done at Covermore. So number one, business mix. So for example, every quarter your manager might ask you, what's the business mix? How is it changing? What you can do is put into some software like Tableau and visually go through each individual factor. You might have a lot of factors, a lot of channels, and quickly, it's not that scalable. So one thing you can do is fit a GBM on top of your policy data set. So your response will be your time variable. So like current period versus previous period. And then based on GBM, you pick out what are the most important factors that predict when the policy was sold. So for example, we might find, okay, age above 80 is a really important predictor for when the policy was sold. Then we know that the mix for the age group is probably changing. And next we can do retail price benchmarking. So you might have a lot of internal rate cards, or you might collect competitors' rates. You might collect tens or hundreds of rate cards. To fully reverse engineer everything takes a lot of effort. What you can do is to quickly build a GBM on the retail price. So yes, you don't need it to be 100% accurate, right? You just need it to be indicative for price benchmarking. So once you got that model, you can apply that to new data sets, and you can quickly assess the competitiveness of your book, of your rates. And finally, you got claim size outliers. So you take your claims data set, which also you also got your policy data sets like your policy characteristics, and then you can use it to detect outliers. For example, in travel insurance, luggage claim typically costs a few $100s or $1,000. If you got a claim is $20,000, that's an outlier. So GBM can help you to quickly identify this and kind of flag create red flags for fraud detection. It can also highlight areas to improve your claims process. So yeah, you might be tempted to use light GBM or GBM everywhere. However, I have to warn you not to do that. There are some limitations. So number one, model smoothness. I think that's quite unique to insurance. So when you set up your retail rates, you always want the rate to go up with your sum insured, right? It doesn't make sense if you increase your sum insured, you get a discount. It's just a bit hard to communicate to your client. And also, I guess access. When you increase your access, you expect the price to come down. Otherwise, there will be some issue with communicating that to the client. So that's when GLM is more useful because it can ensure that smoothness. Very small data sets. So you only have, say, 200 rows of data. You throw a GBM on top of that, it's going to overfit. So in that case, GLM is often a better choice. Very large data sets, I'm talking 10, 20, 100 million rows. So traditionally, GBM can be much slower, and GLM is faster on these large data sets. But as I mentioned, with parallel computing with GPU, this seems to be less of a problem now. And then finally, need to be fully interpretable at a granular level. So I think often Yeah, I'll use a real case. So we wanted to use GBM for an internal, I think, reserving related task, and the actually he's seen both GLM and GBM, um, but he said there's no way for him to stand in front of the board and explain how GBM works. Just too difficult. But GLM, or even GLM can be a challenge. You might end up with a simple table, but still GBM is like too challenging to communicate to the decision makers. So until they get there, it's not wise to try to force them onto the latest and the shiniest machine learning techniques. So that's basically the talk. So I now take some questions.
Thanks, Zeming, for that very interesting talk. And I hope you can see how it might be very readily applicable to your own work and you can get things up and running. So I think we've got time for just one or two questions from the audience. So any takers?
Hi, it's Helen Tai from Mercer. Just on your last point about being able to communicate the models to senior stakeholders, this kind of comes back to the point we had around data literacy. How are you in your organisation trying to, build the bridge between being able to implement these models, but also have the executives to really understand and be on board with it?
Yeah, I think we should just what we do is we really assess the context. So sometimes the execs don't need to go into all the details, right? They just, for example, demand modeling. You just worry about accuracy. The result doesn't actually go outside your analytics area. In that case, you can use the latest machine learning techniques. But for something like reserving, it's highly it's a regulatory requirement, and the board needs to be fully comfortable. They may have never seen machine learning or GBM or light GBM. If you go in and say, okay, I've now got a model, it's a combination of 1,000 individual trees. So I explain, this is my first tree, this is my second tree. I'll show you, I'll lay it all out. You can expect what kind of response you can get. So, and also in that case, it may not matter, right? A simple GLM is okay. So, so even though it takes a bit more time to develop, but it's not the bad thing. So I guess we don't try to convince stakeholders to actively use machine learning, but where we can, we'll try, we'll gradually use it. I think it's still gonna take quite a bit of time. I think over in the next 5 to 10 years, as the younger generation get more mature, get into the positions, they're growing up in the digital age, right? Nowadays anyone from university, they would know about in data science and machine learning, AI. So all that is very natural to them. I expect in future generations this wouldn't be a problem. But currently, yeah, it's still a transition period.
All right. Thanks, Zeming. All right. One more question from Sue.
So very good presentation, thank you. And it's very different from the last two. So this is more focused on like the practical tools. So I want to ask, cause what will, in your experience, what is the best tool to use to build a like GBM or like GBM?
Best tool,
but two parts in terms of coding and building it, as well as in terms of presenting it.
Okay.
Yeah.
I actually quite like H2O. H2O is a machine learning platform. It's open source, it's free. You can have a lot of functionalities already built into H2O. For example, importance matrix, partial dependence plot. The tools that we need to handcraft in other packages, it's already there. Plus, it's also quite scalable. So they are dedicated machine learning platform. On top of that, they also got like a more user-friendly version where you can just point and click. You don't need to code in Python. Yeah, I found that quite useful for new people. Yeah.
Thanks everyone for your questions. If you've got anything else for Zeming, feel free to take the time during lunch to come over and ask him.